This is rocket science. I'm here with my class, physics in Abu Dhabi. We just got finished talking about Dubai and the Burj Khalifa, how big of a building that is and how inefficient it could be relative to energy and conservation of energy, relative to getting water up to the top floor. But anyway, this is about rocket science. And what we're going to do is we're going to take, I would say, probably 20 problems, and they're going to be similar to each other, but we're going to be using equations that are common to you by now. And you will see those equations little by little as we begin. So let's begin. The first rocket problem, number 1, says you have an initial velocity of 100 meters per second. If I have an initial velocity of 100 meters per second, I've got to get time to Dmax, what is Dmax, V at 13 seconds, and D at 13 seconds. So let's begin. So T to Dmax would be literally Vf equals V naught plus G delta T. Solving for V naught, you would get the final velocity would be 0. Does everybody get that? The final velocity is 0 because it rises to the top. And then you would solve for 10 seconds. A quick way to do it would be to simply divide by 10. Simple. So you get that initial velocity, you divide by 10. But in terms of equations, that's the equation you would use. The next one is, how do you get Dmax? Well, this equation, we saw Vf equals V naught plus AT. Well, this one is going to be similar to one that we saw, and that is going to be D equals V naught T plus 1/2 GT squared. Okay, I want to get to the actual top. I'm going my initial velocity, and then I'm going to put it into the equation, and I'm going to get 500 meters. Okay, now the next one is going to be, what is the velocity at 13 seconds? So now understand this. How many seconds does it get to the top? Everybody? 10 seconds, right? So at the top, it's going to be going 0 meters per second. So at 13 seconds, it's falling for how many seconds? 3 seconds, correct? Okay, now let's look at the top. You see, so it's coming down for 3 seconds. So at the 13th second, it goes from rest. So the final velocity at t equals 13 seconds would be V naught plus A delta T, and you'd get 30 meters per second. Okay, we're going to take a quick break, see how we're doing. Be right back, and goodbye. Hey, we're back. Didn't even know I was gone. Okay, now do you see that? It's negative 30. You see, by definition, down is negative for velocity. Up is positive. Up is negative for acceleration. I'll make that a little clearer in class on the board. So the next one is going to be, what's the distance at 13 seconds? So if it's starting from rest, it goes for 3 seconds, okay? And it's going to be going 30 meters per second. You see that? So at the 13th second, it's going to be 30 meters per second times 7 plus 1/2 times 10 times 7 squared. So it will have fallen 455 meters at the 13th second. You see that? Did you see that? Okay, now the next one, we're going to do the same thing, basically. I believe that this is the first one. We're actually going to be doing number 3. I think I go vertical. I go down. So is there everybody pretty good with this so far? Yeah? Okay. So then the next one is going to be, we're going to uncover the velocity, and that's going to be 300 meters per second. So everybody together, what's the time going to be to the top? 30 seconds. Okay, do you get that? Eustace, are you with me? Yeah. Excellent. God bless Lithuania always. Excellent. Okay, good. So the time to Dmax is going to be 30 seconds. And that's a quickie. That's just divided by 10, and there's the work VF equals V naught plus G delta T. Remember, it's actually VF equals V naught plus A delta T. G, because it's gravity, it's going to be a negative velocity because it's going up, etc. So that's going to be 30 meters, 30 seconds to that. Now, let's do Dmax. Dmax is going to be, let's see, what would Dmax be? V naught T plus 1/2 GT squared. It would be, well, the initial velocity to get to the top is 300 meters per second, correct? That's at 0 seconds. And then you multiply it by 30 seconds, because that's the time it takes to travel to that distance. And then negative acceleration, because you're going up is negative, times 30 squared is 4,500 meters. Everybody get that? Slowly but surely? Okay, now the next one is going to be Vmax at 45 seconds. At 45 seconds, is it falling or rising? Everybody, it's falling, because it reaches its max height at 30 seconds, so it's falling for 15 seconds, not 5 seconds, for 15 seconds, right? So if it's falling for 15 seconds, it's going to be going, what? It's going to be going 150 meters per second. Look at the equation, that's how you solve it. VF at 45 seconds equals 0 plus a positive 10 times 15, positive 10 because it's falling. Yes? Yes or no? So it's going to be 150. Negative because when the velocity is down, it's negative. Clear? When the velocity is up, it's positive. When the acceleration is up, it's negative. When the acceleration is down, it's positive. That's the way we do it in here. You're going to see differences of convention, but just understand that's our convention. Clear? I think that's on your mechanics equation sheet. Now at 45 seconds, it's going to be falling for 15 seconds, right? What's V naught at 15 seconds? Because we need to know how high that is off the ground. So it's going to fall for 15 seconds, correct? At 45 seconds, it's been falling for 15 seconds, and it's going to fall for an additional 15 seconds. So it's 150 times 15, and then you have 15 squared, because that's how far you're going. Clear? Are you with me? So you get 3,375 meters. Clear? Now, let's do the next one, and we've got to uncover the initial velocity. Let's look at the time again, time to Dmax. I think that was a little bit confusing. I confused everybody a little bit. So this is going to be, the initial velocity is going to be 200 meters per second. So T to Dmax is going to be what, everybody? How many seconds? 20 seconds. Excellent. Now let's see how that actually occurs. Remember the equation. VF equals V naught plus AT, correct? So VF is 0 equals V naught plus G delta T. Remember, G is negative. How does the V naught get negative? V naught gets negative because you have to subtract it from both sides, correct? So you get V naught equals negative G delta T. Solve for time, and you get 20 seconds. Clear? Now we're back again. You didn't even know I was gone. We're going to go Dmax. What's Dmax? Dmax would be, let's see, would be V naught T plus 1/2 GT squared, right? Yes? So that would be 200 times 20 plus a negative 1/2 10 times 20 squared, correct? Isn't that exactly what it is? So you're going to get 500. Just remember what the initial velocity is. It should be, the initial velocity is what? 200, correct? Yes? Okay. All right. I'm going to take a break for a second, make a fix on the slide, and I'll be right back. All right, so the answer was 2,000. 200 times 20 plus a negative 1/2 g 20 squared would be 2,000. Okay, the next one is going to be the velocity at 30 seconds. So if it's 30 seconds, how long is it falling for at 30 seconds? It would be falling for 10 seconds. Because remember, it's 20 seconds to the top, 20 seconds to the bottom, that's 40. So if it's falling for 30, that means it's at the 10-second mark. 10 times 10 is 10 times 10 is 100, so it's going to be going 100 meters per second, correct? At the end, at the 30th second. And that's exactly what it is. Negative 100 because negative is down. So at the 30th second, it's falling 100 meters per second. And how far down to the bottom is it going to fall? 10 seconds. So it'll be what? It'll be 100 times 10 plus 1/2 10 times 10 squared, correct? And the answer is 180 meters. Yes? Yes? So the next one is going to be, that's 180, and you can see that it starts at 100 meters per second, that's the V naught, and you plug in. You just got to get used to where you are and where you're going. It'll become clearer as we do more and more problems. Okay, the next one is going to be, we're going to do the same routine. So this is 4 similar problems, and by the time you're finished these 4 problems, you'll have a pretty good way, you have a pretty good understanding of what we're going to be doing. Now, you'll see that the next group of problems, we're going to start with something other than V naught. So here we have 400. So let's do the problem, and I'm going to have everybody do the problem, and then I'm going to stop the narration. I'm going to have everybody in the class do the problem and see if they can get it. Then we'll continue with the narration and see what happens. And I'll do the narration a little faster this time around. All right, redoing this, we've got 8 seconds per slide. The first one is 40 seconds. I didn't like the narration. We're doing it, this is take 2. And so you got 40 seconds. And then D max will be V naught T plus 1/2 GT squared. And that'll be 8,000 meters, as you can see here. And then V at T equals 56 seconds will be, it'll be falling for 16 seconds, so it'll be 160 meters per second. And that's correct there. Negative because the down is negative for velocity. And then the last one is going to be it's going to be falling for 24 seconds, starting at 160 meters per second, and that's going to be 6720. And now we're going to start the next one, and I want everybody to look at these, and we're going to start off with these. It's going to be a little slower, the first one, but I told the class that I will go ahead and try to do these, do 5, and then we'll do 6, 7, 8. Okay, so you're starting at 75 seconds, you're at 250. You must have peaked out at what? You must have peaked out, it must have been falling at rest, right? It must have been falling for 25 seconds from rest, correct? So therefore, it's going 250 meters per second because it's falling what? So it must falling for the 75th second. So the rocket must have reached its dy max after 50 seconds. So that's 50 seconds. You see that? Now you can start. Now 50 seconds, if it was rising for 50 seconds, what do I do next? Do I do V naughts? What do I do? Anybody? It reached its D max at 50 seconds. So what must have been its V naught? Anybody? Very good. It must have been 500 meters per second. Now you can put that in, 500 meters per second. So you know it's 500 meters per second. You know the time to D max is what? Is 50 seconds. correct? So now, what's next? We want to know what? We want to know the Dmax, right? The actual height, correct? So the actual height will be what? Will be V naught, which is 500 meters per second. T will be 50 seconds, plus the negative 10, 1/2 the negative 10, so that's negative 5 times 50 squared, correct? So what is that, quickly? Anybody? Anybody have that down? Try to do it. So if it takes, this is the way I do it this one. If it takes 50 seconds to reach the top, so it would take 50 seconds to fall from rest, to reach the ground, so the first term will disappear. I'm doing this a little bit differently in terms of thinking. So if it falls for 50 seconds from rest, it's going to fall 12,500 meters. That was just a different way of looking at it. Did you see that? You're going to want to rewind that. That was just a different way of looking at it. So the last one, the D at 75 meters, so it's going to fall for 25 more meters. So it's going to fall for 25 meters, for 25 seconds. Sorry, it's going to fall for 25 seconds. So it'll be, it's going to start out at 250 meters per second. It's going to fall for 25, plus 1/2 10 times 25 squared is 9,375. Are there any questions with that? Okay, let's try to wrap that up and then see if we can do the next problem while I put this on pause. So you have 9,375 is going to be the distance it's going to fall at t equals 75 seconds. Any questions? Everyone's looking at me with great intelligence. Let's see what happens. Okay, so its velocity is 300 meters per second at the 100 second mark. Okay, now if that's true and it gained velocity of 10 meters per second every second, it must have fallen for 30 seconds. So if it fell for 30 seconds and it's at the 100th second, it must have fallen from rest at Dmax, which was 70 seconds. So at the 70-second mark, it was at rest, meaning it was at Dmax. And then after that, it fell for 30 seconds and reached 300 meters per second. So Dmax, the time at Dmax must have been 70 seconds, and it must have had an initial velocity of 700 meters per second. It clearly says here in this slide, the rocket fell for 30 seconds from rest to the 100th second. So the rocket must have reached its dy max after 70 seconds. So why? Because if it's falling from rest, and we know it is, 300 meters per second divided by 10 is going to be 30 seconds. So 100 minus 30 is 70, clearly. So the time to dy to dmax is going to be 70 seconds. Now the next thing we want to look at is the initial velocity. The initial velocity is going to be essentially 70 times 10. That's easy. That's the short way of doing it. Or we could look at it in terms of the prescribed equation, and that is Vf equals V naught plus GT. You know that Vf is 0 because it's reaching its max. When it reaches its max, the final velocity is 0. So therefore, plugging in, you see that the initial is going to be 700 meters per second. Next, we want to look at Dmax. Dmax is going to be from the equation, d equals v naught t plus 1/2 gt squared. Now, we know that the initial velocity is 700 meters per second. We know that it's going to be traveling for 70 seconds. We know that it's going to decelerate at negative 10 meters per second squared. But looking at it differently, if I know, and everything is symmetrical, I let go of the rocket and it falls for 70 seconds from rest, we know that it's going to fall a distance of 24,500 meters. If you instead put in for V naught is 700 times 70 minus 1/2 gt squared, you'll get the exact same answer. So you may want to verify that. Next, how far off the ground is the rocket at t equals 100 seconds? Well, if the total time it takes to reach the maximum altitude is 70 seconds and it's fallen for 30 seconds, it will fall for an additional 40 seconds. So 300 meters per second, that's what it will be going at that time because it fell for 30 seconds. And you plug into the equation, you can obviously see that it's going to fall for 20,000 additional meters from the 100th second to when it hits the ground. Be right back and take a quick break. So we can clearly see that it's going to be at the 70th second, it's going to be moving down to the ground 300 meters per second, and it's going to take 40 seconds to get down there, and that's where those numbers come from. Very clear. Now, the next one, we're going to start with 400 meters a second at 100 seconds. So obviously it's going to be going for 40 seconds. So it must have reached its maximum altitude at 60 seconds. So it says here the rocket fell for 40 seconds from rest to the 100th second. So the rocket must have reached its dy max after 60 seconds, and that's exactly what happened here. So what we'll do is we'll put in 60 seconds. We'll put in 60 seconds as the time to d max. So that'll be the first answer, and that's what we have here, 60 seconds. Now, the next, we're going to look at what is going to be the initial velocity that the rocket had that came to rest, or it was 0 meters per second at the end of the 60th second. So in order to see that, we know that the final velocity at t equals 60 seconds is going to be 0. It's going to be a negative gravity, and it's going to stop moving at 60 seconds. So plugging that into the equation obviously becomes the initial velocity was positive 600 meters per second. And that's what we're going to put into our chart. Next, we're going to say, okay, well, what was the maximum altitude that it reached? Now, the maximum altitude can take two forms. It can either be the initial velocity 600 times 60 minus 1/2 10 times 60 squared, or simply say, well, at the maximum altitude, if it takes 60 seconds to get up there, and it falls, you drop it, and it accelerates for 60 seconds to hit 600 meters per second, then it's going to go a distance of 18,000 meters, and that'll be the D max, 18,000 meters. Now next, we want to look at what distance will it fall at the 100th second till it hits the ground. Well, it's going to be going, its initial velocity will be 400 meters per second, and then so it's going to be 400 meters per second. It's going to fall for an additional 20 seconds, and then plus 1/2 positive 10 times 20 squared, and that's going to be, D is going to be 10,000 10,000 meters, and that will be the distance it falls from t equals 100 seconds. So the next one we're going to try to get through this next group of problems. And so the next one we have to do is problem number 8, and we're going to be going at 600 meters per second. Well, there's some obvious things here. If it's 600 meters per second at 140 seconds, that means that it must have reached its maximum altitude at 80 seconds and fell for 60 seconds, and to have a velocity of 600 meters per second. That must have been true. So if that's the case, what was the original velocity that the rocket had? Well, the V final at t equals 80 seconds is going to be 0 meters per second, and you're going to have a negative g, and that's going to clearly come out to be 800 meters per second will be the final value. Now, to get the D max, we can either say, well, if it falls 80 seconds from rest, acquires a velocity of 800 meters per second, how far will it fall? And then you can do that, and that's the way we've been doing these last few problems. And as you plug in, you can clearly see that D equals V naught T plus 1/2 GT squared. V naught T cancels to 0, so you're left with 1/2 GT squared. Plug in, you get 32,000 meters per second. Okay, the last is, well, what distance, at T equals 140 seconds, what distance will it fall? Well, let's see. If it reaches its max point at 80, so it would come down to the ground at 160. So at 140, it's got 20 seconds to go. So 20 seconds to go, and it's, again, don't forget, it's going 600 meters per second at t equals 140 seconds. So then 60 times 20 plus 1/2 positive 10 times 20 squared is 14,000, excuse me, 14,000 meters, and that will be the distance. So that's the final answer. 14,000 meters would be the last one we did, because it's 600 times 20 plus 1/2 positive 10 times 20 squared. Okay, the next group of problems, 9, 10, 11, 12, I will give you time to D max, and then you'll have to give me everything else. So the first one is 90, and that would be obvious to me, and hopefully to you by now, that the initial velocity would be 900 meters per second. Well, let's look at the math involved here. We see that the VF at t equals 90 seconds is 0, G is negative 10, T is 90. So plug in, and you solve for V naught as 900 meters per second. 900 meters per second, and then we're going to plug that in. We're going to plug that in to that answer sheet, to the answer sheet. Now, I'm looking ahead, and what I did actually was I did the velocity at 100 seconds. Well, the velocity at 100 seconds would be, if it's 90, takes you 90 seconds to get to the top, it'll be 100 meters per second. There's the math. There's the math, and it'll be 100 meters per second. Okay, will be the final velocity at t equals 100 seconds. So now I'm assuming, let's not go crazy, I'm assuming that I'm going to do d max. I don't know what I'm going to do next, but either way, I could do d max, which would be either 900 times 90 minus 1/2 10, because negative 10 instead of plus negative 10, and then 90 squared, or simply 1/2 positive g 90 squared. And I did the former. I said 900 meters per second times 90 seconds plus 1/2 negative 10 plus 90 squared. Or I could have simply said 1/2 positive 10 90 squared. You'd get the exact same answer. You may want to try that yourself and see if you do indeed get the exact same answer. It was 40,500 meters. The next one, the distance at 100 t equals 100 seconds would be, well, it's going at that time, it's going, v naught is 100 meters per second, and it's going to go 180 seconds, so it's going to go another 80 seconds. So plug that in, and you get 100 times 80 plus 1/2 positive 10 times 80 squared, or 40,000 meters. Now, just a note here, these graphs that I have here are not drawn to scale. That's very, very important distinction here. They're not drawn to scale. Now, the next one is going to be 110 seconds to d max, and I'm going to assume the initial velocity would be 1,100 meters per second. 1,100 meters per second. And that's exactly what the math tells us. The rocket took 110 seconds to rise to the maximum height. At the maximum height, the vertical velocity is 0. If the rocket falls back to Earth for velocity, Vf will be equal to the initial velocity. Okay, so if that's the case, then the math serves us well. So we're going to plug that in, and you get 110, 1,100 meters per second. 1,100 meters per second. Okay, so I'm going to take a quick break, and I'll see you momentarily. You'll never know I was gone. The next one, I'm going to find d max, and that's going to be 1,100 meters per second times 110 seconds plus 1/2 negative 10 times 110 seconds squared, and that's going to be 60,500 meters. Don't forget the initial velocity is going to be 1,100 meters per second, and then we're going to plug that in, 60,500 meters. Now, what's the velocity at time equals 200 seconds? Well, if it's going to take 110 seconds to the max, let's see, it'll take 220 round trip, so it will fall for 90 seconds, so the velocity will be 900 meters per second. That's pretty obvious. And then it'll fall for additional 20 seconds. So when you determine the distance, dm, at 200 seconds, it's going to be 900 times 20 plus 1/2 positive 10, 20 squared. And that should be the distance it's going to fall from, or the height that the rocket is at t equals 200 seconds. Okay, now, so that's it. So 20,000 meters. 20,000 meters, let's take a break. Okay, hard to do this for many slides in a row, but let's take a quick break and I'll be right back. These should be starting to get a little bit more routine. So the answer is 20,000 meters, because at 200 seconds, the rocket is going 900 meters per second, and it's going to continue for another 20 seconds. So put that into the formula and you've got your answer. The next one, at 100 seconds, what's the velocity? Well, at 100 seconds, the initial velocity was 1,000 meters per second. It takes 100 seconds to reach Dmax, and it does so if its initial velocity was 1,000 meters per second. So we'll put 1,000 meters per second into the answer sheet. Now, the next one, I really don't know what I did. I haven't looked ahead. Is it going to be Dmax, V at 135, or D at 135? Well, either way, you could do any of those three, really, before any of the others. So let's see what I did. I'm looking for the Dmax. Well, the Dmax is 1,000 meters per second times 100 seconds plus 1/2 negative gravity, because it's slowing down as it rises, times 100 squared. And that's going to be 50,000 meters. 50,000 meters is the answer to that question. And we'll put that into the magic data table. Now, it takes 100 seconds up and 100 seconds down. So at 35 seconds, it's going to be traveling from rest to 35 seconds. So it would be, the velocity would be 350 meters per second. And there's the math that supports that. It would be 350 meters per second, because you're going up 100, down 100, but at 135 you'll be going down from rest to 35 seconds, which would be 350 meters per second. Now remember, when you're figuring out the distance, the rocket is going 350. So it's going 350 for how many seconds that are left? So what is the height of the rocket? Well, how far will it travel? Well, V naught, which is 350, times whatever time is left over, plus 1/2 times a positive 10, and then 65 seconds. That's the time left over. Why 65? 100 up, 100 down. So at 35, 35 and 65 is 100. So that's 43,875. And then we'll put that in our magic data table. Remember, the G is a positive 10 because it's going down. Right. Next, what happens if it takes 120 seconds to Dmax? Well, it would be 1,200 meters per second, which would be V naught, and then it would be 1,200 times 120 plus a negative, here I have the 1,200, sorry, I was doing the distance for there for a moment. So this is how to figure out the velocity. It should become extremely routine by this point. So how do you do the distance? Well, it's going to be 1,200 times 120 plus a negative 1/2 plus a negative 1/2 G, 10 meters squared, times the time squared. And that's how you're going to figure out the distance. And that calculation is coming up So that's it. 1200 times 120 plus 1/2 negative 10 times 120 squared is 50,000. The initial velocity is 1200 meters per second. Okay? Now, remember, we will go over in class when velocity is positive, when it's negative, when acceleration is positive, when it's negative. Also, please do not forget that these are not drawn to scale. These are not drawn to scale. So that's something to consider before conceptualizing any of this. The next, we're going to figure out at 100 seconds, where is it? Now, this is the first one where it's not descending at the unknown velocity. It's going to be ascending. So at 100 seconds, it's 20 seconds from the top. So it's going to be decreasing 100 seconds times 10, which is 1,000. So it's going to be 1,200 meters per second plus a negative 1,000 is going to equal plus 200. Plus 200 because it's going up. And then to get the distance from that, you would calculate the velocity at the 100 second mark, and then you would simply use the equation relative to a negative acceleration, the time that's left over, and the initial velocity. So it's going to be 200 times 20 plus 1/2, and it's a negative 10 times 20 seconds, because that's what's left over, squared, and you get 6 million. Again, this is not proportional, nor is it real. I'm not sure any of this could really happen. This is just an exercise to go over the various problems. Now, that concludes this particular worksheet, 9 through 12. Now, 9 through 12. Now, what I'll do is I'll introduce the next one slowly, and I'll allow you to work on the problems. So you want to stop when I say, and so we have D max. So if you have D max, you can work backwards for T to D max. Okay? And then everything else should follow through. So you know what? Let's do the first one together, and then I'll speed this up for 15, 14, and 16. Okay, so the isn't it true that the rocket has reached a height of 9,800,000 meters, which is impossible on Earth, and its velocity at Dmax is 0. If the rocket fell back to Earth in ty seconds, you would plug into those values and come up with 1,400 seconds that it would fall back to Earth. So now I have 1,400 seconds. So the velocity is going to be 14,000 meters per second. The velocity is going to be 14,000 meters per second. And therefore, at 1,000, you're going to be 400 seconds shy of the time to Dmax. So let's see what we do next. I'm going to guess that we're going to do V naught, and that's going to be 14,000 meters per second. You're going to want to read this, consider it, look at it carefully, learn something from it, stop it, pause it, rewind it, whatever you have to do. And then we're going to look for the velocity at 1,000 seconds, which again is 400 shy of the Dmax. So V at T of 1,000 seconds, how would you do that? Well, let's see. It's going to have been going 1,000 seconds, so it's going to lose 10,000 meters per second is how much it's going to decrease. So it's going to be 400 seconds, or 4,000 meters per second. 4,000 meters per second at the 1,000 second point. So Vf of t equals 400 seconds is going to be 4,000 meters per second. Next, so it's going to be plus 4,000 because it's going up. And then the distance at 1,000 meters, remember the velocity is going to be 4,000. The time left over is going to be 400 that it's going to be traveling for. And don't forget you have a negative gravity. So that's going to mean that when you plug in, you're going to say 14,000 times the time left over, and then plus 1/2, then that's negative 10 times, again, the time left over squared, and that's your answer. Okay, then you put into the data table, and there you have it. Okay, now I'm going to stop this, and I'm going to allow you to do these problems on your own, and then what I'll do is I'll speed up the next one where it'll be like 8 seconds per frame or 5 seconds per frame, and I'll let it run right to the end with very little discussion about what's going on. Okay, good luck and goodbye. Okay, 7 seconds per slide. The first one is the time in the vertical direction, 1200 seconds. Next, we're going to do V0, and that's obviously going to be 12,000. And then plugging in for D, you're going to have 12,000 times 1,200 plus a negative 1/2, 10, and then 1,200 squared. You'll see that soon enough. Okay, here we have, again, the rocket fell for 600 seconds from rest. Okay, so next we're going to talk about the D at 1,800 seconds distance. Okay, keep going. How are you doing? Don't forget you can rewind this at your leisure to determine whether or not you want to redo one, redo a problem. Okay, we got another 6 or 7 to go. Now the velocity at 1,000 seconds, obviously that's going to be before the Dmax. There it is at 100 seconds from the top. That's going to be a positive 1,000, positive because it's in that direction up, negative velocity down, and the reverse for gravity. And there are the answers. Okay, we'll do a next sheet in a moment. We'll do that right now. Here we go, where it's going to be a mixed bag. You're going to have initial velocities or the time to Dmax. It'll be a little bit of a mixed bag. So we'll do this. We'll do one slowly, the first one slowly in a moment. I'll be right back. Right, so you can see that the first one is going to be 10,000 meters per second, and do the math. The initial velocity is 10,000 meters per second, and it's going to have a time of 1,000 seconds until it achieves a velocity, final velocity of 0 at the d max. Now, we're going to do this first problem slowly, and the next one is going to be, well, what's the distance? What's the d max? Well, the d max would be, you should be able to do this by now using negative g, so it'd be 10,000 times 1,000 minus 1/2 10 times 1,000 squared, and that should be d max. Pretty straightforward. Okay, and you'll get 5 million. Now, obviously, these problems don't make much sense given the dimensions of planet Earth, but again, this is basically an exercise to see if we can get comfortable with the equations. Okay, so the next would be, if it's 1,000 seconds up, 1,000 seconds down, 1,500 seconds would be halfway down. Now remember, again, halfway in terms of time, but not in terms of distance. These graphs that I have are not drawn to scale in terms of distance. So the time would be, the velocity would be 5,000, because it's 500 seconds, and 500 times 10, the simple way to do it is 5,000 meters per second. The velocity will be, well, it's going 5,000 meters per second. It's got to go 500 more meters. So then it would be plus 1/2 and a positive 10, and then the time remaining squared. And that would be the distance at t equals 1,500 seconds. And we'll see that in a minute. Hopefully these are becoming rather simple, almost like busy work. If that's the case, then you're on the edge of understanding this completely. Okay, now, so what I'm going to do is, I'm going to stop this problem in a moment, and then I'll give you a chance to, and I want you to stop it too, I'll give you a chance to do the next problem. Okay? So you see it's 3,750,000 meters, and then the first one starts off at 8,000 meters per second. So I'm going to stop this now and allow you to complete the worksheet page 18, 19, and 20. Okay, be right back. See what you can do. Okay, we're going to go 8 seconds a slide. The first answer is 800 seconds. I'm going to let this play out and allow you to watch it. I'm going to be quiet, and just make sure that you stop, rewind, try to do them yourself, go back and redo it, whatever it takes to master this material. Okay, so I'll stop this at the end of problem 20. Good luck. Okay, the last set of problems is here. How'd you do on the, just the part we finished? Remember to rewind if you have a question. So 21 to 24 we'll do in a moment. I'll be right back, and we'll start with 6,000 meters per second for problem 21. So we started with 6,000 meters per second. We do the math, and we get 600 seconds. So again, there's 24 problems here. So if this isn't second nature to you, you might want to see me after school, and we can go over some of the material that you're caught up on. Okay, so what I'm going to do is I'm going to change the rest of them to 5 seconds each, just 5 seconds, and go through the rest of them. So it'll go fairly quickly if you just want to check your answers. Okay, I'll change it to 5 seconds each if you just want to check your answer, and because of the nature of this, we can just rewind or stop, whatever the case may be. Here's one where you have 6,000 meters per second, 600 seconds to the top, plus 1/2, then a -10 because it's decelerating, and 600 seconds because that's how long the trip is, and make sure you square that. Okay, so I'll be right back. Okay, so I'm going to change this to 4 seconds per slide so that it's going to be very near 1 hour long video. Something that's an hour and a half versus an hour. So again, starting the next slide, it'll be 4 seconds per slide. You can see it's 1,800,000 is Dmax in meters. And we're just going to check your math. So it's going to go very quick now. Good luck. Make sure you see me after school if you have a question. And goodbye. Okay, this is going to end very shortly. If you find any mistakes, make sure you let me know, and extra credit if you find a mistake. Have a great day, and goodbye.